Okay, so we can see up above what our basic log graph looks like. So let's just do a quick sketch of that so it's always forefront in our mind. There's our graph. That's at 1, and I have that vertical asymptote at x equal to 0. Showing axis-intercepts and asymptotes. State the domain of range in each case. All right, so I know the 1 shifts everything across 1, the 3 everything up. So, quick sketch. Everything across 1, so let's move my asymptote first. So that's now at the point where x is equal to 1. That intercept that's normally at 1 is moved across to 2. And if you like, that intercept has moved up 3 units. So the graph itself doesn't look a lot different, okay, in that all that's really changed is that the intercept maybe is a little bit closer to the asymptote. So what do we need to show? Show any axis intercept. So the axis intercepts is at y equal to 0. So at y equal to 0, I get natural log of x minus 1 plus 3 is equal to 0. So I get natural log of x minus 1 is equal to negative 3. The base number is e, so I get e to the minus 3 is equal to x minus 1. X is equal to 1 plus e to the minus 3. So that's my exact coordinate. Okay. Let's state the domain and range. The domain of this graph, okay, is clearly from 1 to infinity, not including. And the range doesn't change, it's still r. So we'll just put negative infinity to infinity will do. Or r, okay. Might run out of room here, but we'll see how we go. Next one looks very similar, doesn't it? So I might do a little graph sketch here because I know it's shifting 2 units to the left. So my asymptote now goes across to here at x equals negative 2, and everything moves down 1. So that y-intercept, which then was at 1, becomes at negative 1. Sorry, the x-intercept. So it goes down to there. And so my graph is just going to look a bit like this. So you can see we're going to have x and y-intercept here. So x-intercept, let's put y is equal to 0. I get 0 is equal to log base e of x plus 2 minus 1. 1 is equal to log base e of x plus 2. So to remove that log expression, I change it into index form. The base is e, so e to the 1 is equal to x plus 2. Therefore, x is equal to e to the 1 minus 2. So that's my intercept. So e minus 2, 0 is the x-intercept. Y-intercept, put x equal to 0. I put x equal to 0. I get y is equal to the natural log of 2 minus 1. So there's my y-intercept. And the domain of this graph, if you look, the asymptote shifted 2 places to the left, so it's from negative 2 to infinity. And the range of that graph is just r. Okay. Let's keep working along, So what happens with negative sign? Flips it upside down, doesn't it? So if it's going to flip it upside down, let's move my asymptote. X minus 1 shifts the asymptote across 1 unit. So x is equal to 1, and my y-intercept is now at 2. But instead of the graph going the traditional way, it's gone upside down, hasn't it? Yeah. So we can sort of see straight away my x-intercept is at the point 20. No y-intercept. The domain is still from 1 to infinity, and my range is still R. Okay, it's just that it's getting there at different rates. All right. What's happening with D? D is we have reflection within the axis. So let's just do a quick graph sketch. Instead of it looking like that, the negative sign there reflects about the y-axis, so it's going to look like that. Yeah. The whole thing shifted up 2 units, and we've got a dilation factor of 2, so everything's increased 2 units from the x-axis, but we don't have any asymptote changes. So what if I just cheat a little bit? There's my asymptote there, still at x equal to 0. That's still that point there, and my graph is just going to look like that. Oop. Oh, I won't do that. Just so it's a bit more. That point moves up 2 units there, and the 2 makes everything a bit bigger. So maybe we just get a little bit deeper. So that's perhaps our graph looks a little bit like that. All right. So we're going to have to find that x-intercept. So the x-intercept, put y equal to 0. So I get 0 is equal to 2 natural log of negative x plus 2. Take the 2 across and divide by 2 is equal to the natural log of minus x. So we get negative 1 equals natural log of minus x, which means the base is e to the minus 1 is equal to minus x. So x is equal to negative e to the minus 1. So there's my intercept. The domain of my graph from the reflection, we can see it's from minus infinity to 0. The range of my graph is still R. All right. Finally, let's just rearrange negative natural log of negative out the front x minus 1 plus 2. So don't forget, always make the coefficient of x to be positive 1. Doesn't matter what sort of function we're looking at, because now we can see we have a negative out the front, so it flips it upside down, a negative inside, so it rotates it about the y-axis, negative 1, so we're shifting it to the right, and we're shifting it up 2 units. So let's just maybe get a bit more space. Good. So let's just do some sketching. So negative, negative. So what does that mean? It goes from that, the negative inside the bracket here, turns it into that. Yeah. And then if you like, the negative there makes it more like that. All right. And there's my, so if you like, that graph in yellow there is negative natural log of negative x at the moment. All right. So then let's just come across a fraction. Let's do another proper graph. I'm now going to shift that whole graph 1 unit to the right. So that asymptote comes there at x equal to 1, and 2 units up. So that point there at negative 1 came across to 0 and then up to there. And so we're going to end up with something like that. Okay, so I think that point there should be 2. So let's check. So y-intercepts, let's put x equal to 0. So I get I get y is equal to negative natural log of negative 0 minus 1 plus 2, negative natural log of 1 plus 2, natural log of 1 is 0, so I get 2 as an answer, so that's a good sign. 0, 2 is my y-intercept. X-intercepts, put y equal to 0. I get 0 is equal to 2 minus natural log 1 minus x. So let's go natural log of 1 minus x is equal to 2. Don't forget that's a base e. So e to the 2 is equal to 1 minus x. So I get x is equal to 1 minus e to the 2. E to the 2 is about 2.7 squared, so it's bigger than 1, so I get a negative x-intercept, which kind of fits in, doesn't it? So there's intercept, so the domain. What is my domain in this case? It's from minus infinity to positive 1. And my range again is R. Okay, so just start with the basic shape and apply all the transformations that we need to. Okay, two ways we can approach. Let's just think about, I guess this one, I think we can just describe everything as it is. It's dilated by a factor of 2, 3 units to the right and 1 unit up, isn't it? So that 2 out the front means my y value gets multiplied. So it's dilated by a factor of 2. Make sure you put from. It's from the x-axis. And we've got translated 3 units. You actually do get away with saying to the right. And translated 1 unit up. Yeah, look, I think that's the easiest way to do it. Let's leave it at that.